Hello, this is Mrs. Mueller. Thank you for joining me today. We're going to do a review of Segment 2 in your Algebra 1 course, focusing on Part 2 of your segment exam. Remember that this section of the exam is multiple choice, and so some of the choices that we go through, some of the choices that we go through are going to have the multiple choices here, and some of them will not. But we're going to go through the concepts in each of them. So when you're graphing polynomials, it is important to keep in mind a couple things. Two things are going to be important to you. Number one, the end behavior, which comes from determining what do the ends of the graph look like? Are they going upward, downward, that sort of thing. And so that's what we're going to be looking for. And the way we determine the end behavior is by looking at this leading term here. The leading coefficient, the number in front of the variable, is going to tell us what the right side of the graph is doing over here, whether it's going up or it's going down. The right side of your graph comes from the leading coefficient. Now the trick is just recognizing if it's positive or negative. And this really makes common sense. If it is positive, then the end of your graph is going to go up. If it is negative, then the end of your graph is going to go down. So in this case, we notice that our leading coefficient is a 1, even though it's not written there. We understand it's a 1, which makes it positive, and that tells us that our graph in this example is going to end up. We have to figure out what the beginning of our graph is doing, and that comes from the degree. So the degree of this polynomial is going to tell us the beginning of the graph, and this is how it works. If the degree is even, then the beginning of the graph is going to be the same as the end of the graph. The left side is going to be the same as the right side. If the degree is an odd number, then it's going to be different from the other one. It's going to be in the opposite direction. Okay, so we see in this particular example, our degree is 3. It is odd. And so that tells us that the beginning of our graph is going to be in the opposite direction as the end of the graph. So the beginning of the graph is going to be pointing down. The end of the graph is going to be pointing up, according to our leading coefficient and our degree. We need both of these pieces of information in order to be able to determine that. So when we look at our answer choices, let's see what it's telling us. In the first one, it starts down on the left and goes up on the right. Well, that's true. It's going down on the left and up on the right. So that's a possibility. For the second one, it starts down on the left, goes up on the right. That is true. The third one, it starts up on the left and goes down on the right. And that's not true for this example. And same thing with the fourth choice. Goes up on the left, down on the right. Not true. So we know already that these two answer choices are not correct. So we're going to focus on the first two choices. The second part to this problem is telling us that the graph intersects the x-axis at these 3 points. And so when we compare these two answer choices, notice that they both have -1 as their as possibilities. They both have 3 as possibilities. So the only difference is when x equals 2 or x equals 1. And so those are the only things we need to focus on. So in order to determine whether this graph intersects the x-axis at these locations, remember when it crosses the x-axis, it's called a 0. That's a 0 of the function. And so that means the function is equal to 0. So what we're going to do, because this is multiple choice, this makes it a little easier for us, we're going to take the 2 and we're going to plug it into this equation for all of the x's, and we're going to see if it does in fact equal 0. If it does equal 0, then it's correct. If it does not equal 0, then we know this is not the correct answer. And so we move down here at the bottom. We're going to take 2 to the 3rd power minus 3 times 2 squared minus 2 plus 3. And then simplify it using our order of operations. Exponents first. 2 to the 3rd power is 8. 2 squared is 4, and then I'm going to multiply it by 3. So that gives me 12. Minus 2 plus 3. And then 8 minus 12 is 4 minus 2 plus 3 is like negative 3 as our answer, which is not 0. Remember, we wanted it to equal 0 if it's going to be a point on our x-axis. So we know this is not the correct answer. This one would be the correct answer, and you can double check that. But again, if you plugged in the 1 for each of those x values in the function, you would see that your answer would equal 0. And so that's how we determine that. So again, graphing polynomials, looking at the end behavior is going to be helpful to determine if it opens up or down. You know what the ends do, if they're going up, if they're in the same direction or different directions, and determine that by looking at the leading coefficient, the number in front of the in front of that first term with the highest exponent. That's your leading coefficient. If it's positive, the right side goes up. If it's negative, the right side goes down. And then you look at the degree. If it's an even number, then the left side of your graph is going to be the same as the right side of the graph. They're both pointing in the same direction. And if it's an odd number, they're going in opposite directions. All right, so let's focus on this question down here. This is a similar type question. Again, remember it's multiple choice, and so you would be given 4 graphs that potentially will represent what this function looks like. And so which graph shows the quadratic function? Again, we're going to focus on some things here. Let me erase what I have up here and cover it up so it is out of our way. And we can work on it. Okay. So I have a little hint down here, but before we talk about that hint, let's talk about what the ends of this graph are going to look like. Again, remember, you're going to have 4 pictures of graphs that you're going to see. We want to try to eliminate any of the possibilities. And so when looking at this leading term, notice that the leading coefficient is positive. So because it's positive, we know that the right side of the graph is going to go upward. It is an even degree this time. 2 is an even number, which tells us because it's even, it's going in the same direction as the other side. So both ends are going to be pointing up. This is going to look something like this when we graph it. Now, if all of the pictures, all of the answer choices have graphs that point upward like this, then we have to go a little bit further. If some of them point downward or look differently than this, we can eliminate them because we've already determined our answer has to look like this. Now, let's look at our hint. Find the vertex. Because what's going to happen is this. You're going to see pictures that are going to be on your coordinate plane, and this parabola could be anywhere on that coordinate plane. So we want to figure out where the vertex is. This is going to be important. The vertex, remember, is this bend in the parabola. It's that point, that bottom point or top point, it's the bend where it switches directions. And so we want to figure out where that's located, because I can almost guarantee you that is what is going to be different in these different graphs that you see. So remember how to find the vertex. We have a little formula for it. X equals negative b divided by 2a. Remember, the b and the a come from the function itself. Let me get rid of some of this stuff so we can see what the a and b come from. The equation, remember, comes as ax squared plus bx plus c. So when we have these little formulas with a and b and c in it, it comes from the location in your function. So notice that the a is always the number in front of the x squared. So in this case, a is going to be 3. B is always the number in front of the x. So in this case, b is 12. And the c is always the number by itself. It's the constant out here. So c would be 14 in this case. So in order to find the vertex of this polynomial, negative b means we're going to take the opposite sign of b. So we're going to take negative 12 divided by 2 times a, and a in this case is 3. And then we simplify. So negative 12 divided by 6 looks like negative 2. So because of this, now I know that this graph is going to be at x equals negative 2. Right here at negative 2, this is where the vertex is going to be located. If there are multiple graphs where this is on negative 2, on that negative 2 line, then we have to go a little bit further. We have to figure out how high or how low that vertex is going to be on that line. And we can do that. We're going to take the negative 2 that we just found, and we're going to plug it back into the x in each of those parts of the function. So we would do y equals 3 times negative 2 squared plus 12 times negative 2 plus 14. And simplifying, so y equals order of operations tells us to use the exponents first in this case. So negative 2 squared is going to be a positive 4. Positive 4 times 3 gives us 12. And then 12 times negative 2 is negative 24. And then plus 14 on the end. And simplify, we get y equals, this looks like negative 12 plus 14 looks like a positive 2. So we would have a vertex at negative 2, positive 2. And so this would be up here at positive 2. And that would be the graph that we focus on. So, again, just a reminder, graphing polynomials, it's going to be important for us to recognize, number one, what the ends of the graph are doing, whether they're pointing up or down, same or different, and where the vertex of the parabola is located, and we use this little vertex formula to do that. All right, so we're going to see several examples of these. Another quadratic function type problem. A punter kicks a football upward with an initial speed of 48 feet per second. After how many seconds does the ball hit the ground? Use the formula. This is nice. They give us the formula right here. Use the formula h equals rt minus 16t squared, where h represents the height in feet and r represents the initial speed. All right. So they give us this formula. We're going to plug in some information that they tell us. H is the height, R is the initial speed, and T represents the number of seconds. It's the time. And that's what this question is asking us. That's important to recognize. After how many seconds does the ball hit the ground? So we're solving for T. The other thing that this problem tells us, and this is kind of tricky, you need to look closely for it, but it also tells us what h is. Remember, h is the height of the football from the ground. And if we're trying to determine when the ball hits the ground, think about what height that would represent. If it's on the ground, it's going to be a height of 0. So h is going to equal 0 in this problem. And that happens a lot. If it's on the ground, you're just setting your equation equal to 0. Here's what we know so far. The height is 0 equals r is the initial speed. They tell us the initial speed is 48 feet per second. So I'm going to put 48 for r multiplied by t minus 16 squared. And now we need to solve for t. Because this is equal to 0, we can see that it is factorable. We can factor out the GCF, the greatest common factor in both of these terms. Notice, let me help you out here if you want to break these down to their factor trees. This is 2 times 24. 24 breaks down into 2 times 12. 12 breaks down into 2 times 6. 6 breaks down into 2 times 3. And 2 times 2 times 2 times 2 times 3. 16 breaks down into 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. And so we have 2 times 2 times 2 times 2. What do they have in common? They both have 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2 means that they have 16 in common. 16 is our GCF. And then also look at the variables. Notice that there's 1 p in this first term, and there's 2 p's in the second term. That p squared means p times p. And just notice they both have 1 p in common. That will be part of our GCF. So we're going to factor out the GCF. So this is going to be 0 equals 16p. And then what's left? If we factor out 16p out of that first term, notice that there's still a 3 left over. The p is already gone. So this is just going to be 3. And then in the second term up here, the 16 factored out. The only thing that's left is a 1, basically, but we don't need to write that. One of the t's came out, and there's 1 t left. So this is just 3 minus t left over. So once we have it completely factored, which it is, we factored out that GCF, it's completely factored, we're going to set each factor equal to 0. So 16t equals 0, and then we're going to solve it. And 3 minus t equals 0. And we're going to solve that as well. So back to the first one, 16t equals 0. We divide by 16. 0 divided by 16 is just 0, so we get t equals 0 is our answer. Over here, I'm going to add the t to the other side to make it positive, which gives me 3 equals t. And that is the answer as well. So then we need to look back at the question. Again, this is a multiple choice question, so that will help you out. But remember what it's asking. After how many seconds does the ball hit the ground? Well, when you're kicking a football, it starts on the ground, and then it lands on the ground again. When it starts on the ground, that's when time equals 0. That's before we did anything. So this is not what the question is asking for. It wants to know after how many seconds does it hit the ground, and that would be t equals 3. 3 seconds would be our answer. All right. Let me remove this stuff. We've got another question under here. And let me cover up what we did up here. There we go. So we can focus on the second question. This time we are given 2 functions graphed on the same coordinate plane. They tell us the graphs of functions f of x and g of x are shown below. Notice which one is which. F of x is the curved parabola. G of x is this line. So we've got the 2 functions graphed, and the question is, what are the solutions to the equation f of x equals g of x? When do these 2 functions equal each other? When you're looking at the graph, you should recognize that they're going to equal each other wherever they intersect. They're going to have the exact same ordered pairs in those 2 positions. And so we're going to look to see where those are. This first one looks like it's at -4 and up 8. So -4, 8. be one solution. And then for the second one, it looks like it's at 2.5 and maybe negative 8.1, maybe. Okay, again, multiple choice question. You're looking for the one that has the closest answer to that. And that's it. Solutions to where those graphs are equal to each other is where they're intersecting. Okay, so we move into factoring. This is now Module 8 that we're focusing on, and we've got 3 examples here on how to factor 3 different types of situations. So this first one, we need to recognize, first of all, that it represents a pattern. This is called the difference of squares. It only has 2 terms in it. We notice that the first term is a perfect square number, and the last term is a perfect square number, and they're being subtracted. And so that's what it means when it says difference of 2 squares. So difference of squares. This has a nice little pattern that we factor it into. So think of the perfect square numbers as 49 breaks into 7 times 7, and 25 breaks into 5 times 5. And again, same thing with the variable. The x squared splits into x and x. And so what we're going to do is this is going to factor into 2 binomials. We're going to put in the first position in each of these binomials the factors of the first term. And so basically split it, 7x and 7x. So we're going to get a 7x here and a 7x here. And we're doing the same thing in the second position. We're going to take the second term in our polynomial and split it. 25 breaks into 5 and 5, so 5 and 5 goes in the second position. And then in order to get this negative 25, recognize that one of the 5's has to be a positive and one of them has to be a negative. So these signs are always going to be different between them. One is always positive, one is always negative. That's the pattern. So the difference of squares simply factors into splitting the first term and splitting the second term. One's positive, one's negative. All right, so when we look at a polynomial that is a trinomial, it's got 3 terms here. The first is always going to factor according to the greatest common factor. So when we look at these 3 terms right here, we have to look to see what do they have in common. Well, 6 is a common factor of all 3 of those terms. So the GCF is going to be 6, but then also notice that the first term has 3 m's, the second term has 2 m's, and the third term has 1 m. So they all have at least 1 m involved, and so we're going to pull that out of our GCF also. So GCF is 6m, and then we're going to divide each term by 6m. Okay, dividing it, that's really what factoring is dividing out the common terms and determine what's left. So when we divide this by 6m, we get 3m squared left over in the first term. In the second term, we're going to have a negative 2m left over. And in the third term, when we divide 6m by 6m, it is simply going to be 1. So there's the factorization of this trinomial. Now, you always want to make sure that after you've pulled out this GCF, we want to look at what's left in the parentheses. Notice that it is still a trinomial, and it actually follows the pattern of a trinomial, where you have a squared term, a linear term, and a constant term. And so we need to check to see, does this factor further? Can we factor what's left in the parentheses? And so let's talk about how we're going to factor a trinomial. The first thing we're going to do, and these are different colors so we can see what's happening here. The first thing we're going to do is we're going to take the first term, actually just the number, the coefficient, and multiply it with the constant term. So we're going to take the 2 numbers on the outsides of the trinomial, and we're going to multiply them together. So when we take 3 times 1, we get a positive 3. And then we're going to factor this number. So 3 only has 2 factors, 1 times 3. Okay, you could have a whole list of factors, things that multiply together to equal that number. But in this case, we only have 1 and 3. Now, because this is a positive 3, that tells us some important information. That means that both of the signs of these factors have to be the same. Either they're both going to be positive or they're both going to be negative. And we determine that by the middle term, because I want to look for the factors that are going to add up to the middle term. So I'm looking for, is there any way to add these two numbers together, the 1 and the 3, so that I get a negative 2? And so because this is a negative, I know that both of these signs have to be the same, because it's a plus 3 here, and negative 1 times negative 3 gives us a positive 3. But when I add them together, I get negative 4. And that's the only thing I'm going to get. There's no other way I can combine this together to equal a negative 2. So that tells me that this does not factor any further. If I found a combination that added up to negative 2, then I will be able to continue factoring it. But this is as far as it goes. So our final answer for this one is simply 6m multiplied with 3m squared minus 2m plus 1. And that's it. So let's move on to the third type of factoring here. Now this one, the question is a little different. And again, remember, these are all multiple choice questions. So you will have things that you can look at to determine that. And honestly, with factoring, one of the ways you can always double check your answer to see if it's correct, you can multiply it back through. Remember, you can distribute and determine if you multiply this back out, does it equal what you started with? Okay, so that's how you can check your work. Same thing here. Multiply it back out, is it what you started with? Okay, so back to this third problem here. This question says, which of the following is an actual zero of the function? Okay, well, first of all, recognize what zero means. Zero means we're setting the function equal to 0 and solving it. So this is what our function really looks like, setting it equal to 0. But in order to do this, we're going to factor it. Notice, and this is solving it, find the actual 0 means solve. So in order to factor a polynomial that has 4 terms in it, you should recognize that this is going to involve grouping. Grouping is what you're going to do anytime you have 4 terms in your polynomial. So grouping looks like this. You're going to first group the first 2 terms together, and you're going to group the last 2 terms together. That's the grouping process. Once you've done that, now you're just going to calculate the GCF for each group. So when I look at this first group, the x cubed plus x squared, I'm trying to determine what do they have in common. What's the greatest common factor that they have that I can pull out? And I see here that they both have at least 2 x's, right? So I'm going to factor out in the first group, I'm going to factor out x squared. And then what's left? Well, if I divide the x squared out of both terms, remember this is really what we're doing, we're dividing by the greatest common factor, I'm left with 1x in the first term, and then x squared divided by x squared is just 1. Here's the first group factored. I'm going to do the same thing with the second group now. If I look at the negative 4x minus 4, what do they have in common? Well, they both have the negative 4 that I can pull out. So I'm going to pull out a negative 4. And again, we're going to divide both terms by negative 4. And what happens? Well, in the first one, I'm just left with x. In the second one, negative 4 divided by negative 4 is a positive 1. So I factored the second group by pulling out that GCF. At this point, we are not done yet because we still have a plus or minus sign between some of our parentheses and numbers. Okay, so we don't want that to happen. When we completely factor it, it's going to look like it does up here. It's going to have two sets of parentheses multiplied together. And so we have to do our final step. And in this case, in all cases with grouping, notice that the parentheses have the same things in them. This has to happen in order to be able to factor it completely. So if these parentheses are not the same, one of two things have happened. Either you've made a mistake in your calculations, or it's not factorable. You've done everything correctly, but it just doesn't factor any further. All right, so these are the same, so here's how we finish it. In our two parentheses, we're going to have the stuff on the inside, the x plus 1 goes in one of the parentheses, and then the stuff on the outside goes in the other parentheses. The x squared minus 4 goes inside the other parentheses. And so this is factored. We could, again, just double checking that we factored it completely, notice that in this parentheses, this follows the difference of squares pattern that we talked about up here in the first example. Because this is a perfect square term, this is a perfect square number, they're being subtracted. So this we can follow the pattern we did up here at the top, and we can factor this further. This is now going to factor into two sets of parentheses again. Remember how this worked. We're going to split the first term, so x squared is just going to split into x and x, first positions. 4 is going to split into 2 times 2, so 2 is going to go in the second positions. One of them is plus, one of them is minus. And so the x squared minus 4 factors into x plus 2, x minus 2. The x plus 1 we're going to keep as part of our answer. X plus 1 is going to be multiplied with that as well. And so this is the complete factored form for this polynomial over here, this function. Now, we have to make sure we answer the question. The question said, which of the following is the actual 0? Once we have factored it, remember it was all equal to 0. And so we're going to finish by setting this equal to 0. And the way that we solve is by setting each factor equal to 0. So x plus 1 equals 0. X plus 2 equals 0. And x minus 2 equals 0. Solve each of those simple equations. We're going to subtract 1 in the first one, so x equals negative 1 is one of our answers. Subtract 2 in the second one, so x equals negative 2 is one of our answers. And add 2, so x equals positive 2 is an answer. And those are the three zeros. All right, so moving forward, we're going to look at analyzing functions and graphs. So the following function shows the relationship between the selling price S and the profit P of S in dollars for a company. And it's nice, they provide for us the function that we're going to look at, this relationship that's already provided for us. So the question is, which statement best describes the intervals where the company's profit increases, decreases, or records a maximum? Some key things that we need to get out of this question. Number one, maximum. This is a very, very important word. It's a key word. Anytime you see a question that asks about a maximum or a minimum, automatically you need to recognize it's talking about the vertex. All right, so anytime you see maximum or minimum, you are going to use your vertex formula. Remember, it was x equals negative b divided by 2a. And as we look at this function up here, let's also take a look at what the graph is going to look like. Just a general description of the graph. I'm a very visual person, so I like to think through what it looks like, and it helps me to recognize what my answer should look like. So remember what we've already talked about with functions. We're going to look at this first term, this leading term. We're going to look at the leading coefficient, whether it's positive or negative. In this case, the leading coefficient is negative 20. It's negative, so that tells us that the end of our graph on the right-hand side is going down. The next thing we're going to look at is the degree. Remember the degree, whether it's even or odd. In this case, the degree is 2, which is even. And because it's even, remember, the first part of our graph is doing the same thing as the last part. So our graph is going to do something like this, according to our leading coefficient and our degree. So I have something kind of in general. If this is my coordinate plane up here, then my graph is going to do something like this. I don't know exactly where it is, but I know that it's looking something like that. And so I need to find the vertex. The vertex is up here, and this should make sense to us for what the question is asking. It wants us to know where the maximum is. So this is the point at which there's a maximum. It's at the vertex. So now I'm going to use the information in my problem and plug into my vertex formula. The b in this case, remember, is the number in front of the linear term. So my b is going to be 1400. The a is going to be negative 20. And the c, which I don't really need right now, is negative 12,000. So my vertex, x equals negative b means I'm changing the sign of b. So negative 1400 divided by 2 times a in this case is negative 20. And then simplify, so negative 1400 divided by negative 40 gives us positive 35. So I know that my vertex, this location right here, the x value is at 35. Now I don't know how high it is, but that's okay because that's not what the question is asking me. Let's look at our answer choices at this point. So when I look at these answer choices, I'm looking at these values right here, and I can see already that 35 is the point at which I have a maximum. And so these problems with 30 in them, these answers with 30, I know are going to be incorrect. Those are not going to be the correct answer choice, so I'm going to eliminate them. Now I need to look at what the answer choices for the third and fourth ones are actually telling me. For the third one, it says it decreases when the selling price increases beyond 35. Again, the question is saying, which statement best describes the intervals where the company's profit increases, decreases, or records a maximum? The profit decreases when the selling price increases beyond 35. So let's look at our graph. Here's 35. 35 is going to increase this way. When the price increases past 35 or increases beyond 35, what is happening to our profit? This graph is showing me that my maximum is at 35 and then my profit is decreasing. And that's what this is saying. It decreases when the selling price increases beyond 35. So that would be our answer choice right there, C. We can see that the last one is not the correct answer because it's telling us it increases when the selling price increases beyond 35. And so our function is totally not increasing, it is decreasing. Let's see how that works. Still analyzing functions and graphs, kind of the same idea, just a different type of question. A basketball is thrown upwards. The height, f of t in feet of the basketball at time t in seconds is given by this function. Again, they tell us what the function is. Excellent. Which of the following is a reasonable domain of the graph of the function when the basketball falls from its maximum height to the ground? All right. Some keywords again. We see the word maximum, and we just talked about the fact that that's important it tells us that we need to find the vertex. And so we're going to use our formula again, x equals negative b divided by 2a. In this case, negative b is going to be a negative 94 divided by 2 times a. A in this case is negative 16. And simplify. So negative 94 divided by negative 32 looks like positive 2.94, I believe, something close to that. And so that's where the vertex x value is going to be. Again, let's do a little visual here. Let's look at what the graph is going to look like. This negative 16 tells me that the right side of my graph is pointing down. The even degree tells me that the left side of the graph is also pointing down, so I've got a graph that looks like this again. My visual so I can see everything that's going on. Plane, I've got a basketball that's doing something like this. And this makes sense, right? The basketball's thrown upward and it comes back down. That's what we would expect it to look like. This maximum point we just determined is at 2.94, or 2.9 something. I can't remember exactly what it is, but you can calculate that. Good. So we have kind of a visual of what's going on here. So let's look at the question again. Which of the following is a reasonable domain of the graph? What does domain mean? Domain is talking about your x values. In this case, we don't have x's, we have t's. So it's looking at the t values, the time. What is a reasonable time for when the basketball falls from its maximum height to the ground? So here's the maximum height up here at the top, down to the ground, down here. So we want to know how much time that takes. Well, that refers to the domain along the x-axis. So it started at 2.94 and it's ending somewhere. So when we look at these answer choices over here, which one makes sense from the maximum to where it hits the ground? It's starting at 2.94, so we can already eliminate this one and this one. These are not close to starting at 2.94. This one starts at 1, this one starts at 0. So between these two, which one makes more sense? And you should find that 2.94 is a lot closer to 3. 3 is going to be right past this maximum right here, which still makes sense in our problem, all the way down to whatever time it takes down here. You should see that this first answer choice is the best. All right, completing the square. This is a technique used to solve quadratic equations. So we're given a quadratic equation. We want to complete the square in order to turn it into vertex form. Now, you might recognize vertex form a little differently. I think in the lesson it says x minus h squared plus k is your vertex form. Okay, well that's really what's happening here. Instead of h and k, we're using p and q. And also notice that the q is moved over to the other side of the equal sign. So this situation would mean that k is moved over here when f of x equals 0. Okay, and that's what you would do. It would be equal to 0 when you're solving it. So you would move the k over here. So the question is, which of the following is the first correct step to write the above equation in vertex form? The whole idea revolves around this number right here. We want to create a perfect square trinomial, which means we want to be able to factor this trinomial into something squared. Okay, that's our whole purpose. And when I say something squared, I'm talking about when we factor this trinomial, the two things in parentheses are going to be the exact same thing, so we can write it in something squared. So how do we do that? Well, the first thing we're going to recognize is that in order to determine what this number has to be a perfect square, we're going to take the middle term, this linear term, and we're going to divide it by 2. So we're going to take negative 8 divided by 2 equals negative 4, and then we're going to square that answer, and that is what the number needs to be in order to have a perfect square trinomial. So we would have x squared minus 8x plus 16. And when we factor that, it will factor into x minus 4 and x minus 4, which turns into x minus 4 squared. That's exactly what we wanted to have happen. So, our problem was not 16 though. The problem actually had 13 in it. So the question is, which is the first correct step to write it into vertex form? How do we change this 13 into a 16 so that it becomes a perfect square trinomial? You should see that we're going to add 3 to both sides of the equation. Because remember, what we do to one side of the equation, if we add 3 here to make this 16, then we have to add 3 to the other side to keep it balanced. If we just add 3 to the 13, we've changed the problem completely. But if we add 3 to the 13 and also add it to the other side of the equation, it is still balanced. It has the same value as the original equation. That's the idea behind this completing the square. All right, moving on, comparing some functions. A company launched 4 new products. The market price in dollars of the 4 products after a different number of years is shown above. Based on the data given, the price of which product will eventually exceed all others? And here's some key information. If we want it to eventually exceed, we're looking at the function that grows the fastest. And it grows the most. And it doesn't matter whether it's the fastest at the beginning, but by the end, it's going to be growing the most. And that only happens when you have an exponential function. So we're looking at which of these pieces of data show us an exponential function. The way that we're going to recognize that is if it is multiplied by the same thing in each from year to year. Multiplied by the same thing, same number from year to year. So when we look at this first product right here, notice that in year 1 it was 2, in year 2 it was 4, year 3 is 8, year 4 is 16. So you can see that to go from year 1 to 2, we have to multiply by 2. So 2 times 2 gives us a 4. To go from year 2 to 3, we multiply by 2 again. 4 times 2 is 8. And from 3 to 4, multiply by 2 again. 8 times 2 is 16. And we would continue this process. That right there is an exponential function. Because basically what's happening is this. If we take this original amount and raise it to the first power, that's the first year, that equals 2. If we take 2 to the second power, then we get the amount for the second year, 4. If we take 2, which was the original amount, to the third year, we get 8, and that's what we get for the third year. And then 2 to the fourth year gives us 16. So you can see it is exponential because it's something that's raised to the power. It's the same number raised to the power for each year. And we see that with the multiplication. You will notice that products 2, 3, and 4 do not have that same situation. So for example, we can see in product 2, to go from year 1 to year 2, we're adding 2.6 to it. From year 2 to 3, we are adding, looks like 1.6, so we're adding a little less. And then we're going to add, this is, what is it, 4. So it's very inconsistent in product 2. Product 3, if you notice by year 4, has grown the most, even compared to year 1. But if you look at the trend, what's happening with it, in product 3, this is being added 4.2, and then we're adding 5.2, and then we're adding 7.2. So we're adding more each time, but again, we're just adding. So even if we follow that trend, maybe this would be, we're adding 10.2. Eventually, the multiplication is going to exceed it. So you should see that product 1 is the one that will eventually exceed all others because it's multiplying, it's growing exponentially. And then product 4, you can see that it's increasing and then it decreases. So it's not even doing a consistent increase all the time. So product 1, comparing functions, exponential functions will always eventually exceed all others. It will grow the fastest once it hits a certain point. All right, solving some more quadratic equations. They give us, we've got 2 different problems here, so let me cover up this problem for just a moment and focus on this top problem. One solution of the equation 4x squared minus 9x plus 5 equals 0 is 5/4. They're telling us one of the solutions. Again, this is a multiple choice question. They want to know what is the other solution. There's a couple of ways you can solve this because it's multiple choice. Take the answer choices that they give you and plug them into the x values and see if they work. When you plug in those answer choices, do they equal 0? If they do, then that's your answer. And only one of them should work. Okay? Again, that's the shortcut to doing multiple choice. But let's talk through how you would tackle this problem if it wasn't multiple choice. So in this situation, this is a good opportunity for us to practice factoring again. We have a trinomial, and we want to factor it. So remember, we're going to take the first term and the last term, and we're going to multiply them together. That gives us a positive 20. And then we're going to factor 20. All the factors of 20 are 1 times 20, 2 times 10, 4 times 5. And then it starts repeating, 5 times 4, 10 times 2, 20 times 1. So these are all of the factoring options for 20. Remember this positive 20 tells us that it's going to have the same signs. These numbers down here are going to have the same signs. Either they're both going to be positive or they're both going to be negative. And because this middle term is a negative, I know that they're both going to be negative. So the question is, which ones add up to the middle term? Which ones are going to add up to negative 9? And you should see, it's not the first one, it's not the second one, but it is the third one. That means we are going to use these 2 terms, these 2 numbers, and rewrite our problem. So we're going to change our trinomial of 3 terms into a polynomial with 4 terms. Instead of writing negative 9x, I'm going to replace it with negative 4x and negative 5x. Like this. 4x squared minus 4x minus 5x is a constant plus 5. Notice all I did, I kept the first term, I kept the last term, but I rewrote that middle term and I split it into 4x, negative 4x, and negative 5x. The reason we do that is because now we can group. And again, we're going to practice that grouping process. We group the first 2 terms, we group the second 2 terms, and we're going to factor out the GCF. What do the first 2 terms have in common? They both have a 4, and they both have an x. When we do this, we're really dividing by 4x in both cases. 4's cancel. One of the x's cancel, but I'm left with an x left over. Negative 4x divided by 4x gives me negative 1 for the second term. That's the grouping factorization for the first group. For the second group, I'm going to use this middle sign, this minus sign that's in between here. I'm going to use that as part of my GCF. So I'm going to factor out a negative, and then they both have a 5 in common. So negative 5 is what I'm factoring out. Again, I'm going to divide both terms by negative 5, which gives me a positive x. Negative 5 are going to cancel and left with a positive x. And then 5 divided by negative 5 means fit negative 1 left over. And remember what we talked about before. What's left in parentheses has to be the same. It is. That's awesome. So now we complete our factorization. The first parentheses is going to be the stuff in the parentheses, the x minus 1 is in both of them. The second parentheses is going to be the stuff on the outside. So the 4x minus 5 goes in the other parentheses. So we have completely factored this trinomial up here. Factorization for it. Remember, if we're solving it, we're setting each factor equal to 0. So x minus 1 equals 0, and 4x minus 5 equals 0. You should recognize that this answer, 5/4, that they gave us, comes from this equation. If we add 5 to both sides, and then divide by 4, x equals 5/4. So that's the answer that they gave us. This other equation, x minus 1, when we solve it, is going to be the other solution that they're looking for. Okay, so one of your answer choices would say x equals 1, and that's what we would choose. Again, we talked about if it's multiple choice, you could just take those answers and plug them into the x values right here and right here and simplify this, and if it equals 0, it would work. So x equals 1, then we plug it in, it would work. All right. Let's erase some of this information, and let's look at the next question. This time, they're giving us a quadratic. This is already in vertex form, right? This is that h minus k squared equals x minus h squared equals k. And it's asking what is the approximate positive value of x. Well, because it's already in this form, we're trying to solve for x, but this form helps us a little bit because we don't need to multiply out. We don't have to FOIL this out and try to figure out what x squared is or factor it or anything of that sort. It's already done for us. The only thing that we're going to do is get x by itself. And the way that we do that is first by getting rid of this little squared exponent. So remember, the opposite of squaring something is taking the square root of it. That is going to allow us to cancel out that operation. But when you take the square root of one side, you have to take the square root of the other side to keep it balanced. That's just like when we solve any equation. We have to do the same thing to both sides, and we're doing the opposite of both things, of whatever the operation is. So the opposite of squaring is taking the square root. Those are going to cancel out, and we're left with x plus 1 equals the square root of 55. Since we're finding the approximate value, I'm just going to plug square root 55 on my calculator, and it's going to give me something like 7.42. So x plus 1 equals 7.42. And finish solving for x. Subtract 1. X equals 6.42 is going to be our answer. All right, still solving quadratics. What are the exact values or the exact solutions of this quadratic equation? This one's going to be a little trickier to do by just plugging in answers, because when it says exact solutions, this usually means you're going to have a square root in your answer. And those are more difficult to work with. Exact solutions are not decimals. Okay, so if you have any answer choices that are decimals, probably not the correct answer. You want exact solutions in the form of square roots. So we're going to use what's known as the quadratic formula to do this. The quadratic formula, if you remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice this formula is very similar to what we've been using. The x equals negative b over 2a is there, negative b over 2a. This is your vertex that we've been using a lot of. But this plus or minus square root over here, this is going to help us to solve the equation. So we need to know what a, b, and c is in this equation. In this case, a equals 1, it's the number in front of the x squared. B equals 5. C equals 1. And so we plug in those values. X equals negative b means I'm changing the sign. So negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 1, times b, which is 1. C, 4ac, c is 1, all over 2 times a. And simplify. So negative 5 plus or minus inside that square root. Order of operations tells us we're going to do 5 squared first, and then we're going to multiply second. So 5 squared is 25. We've got the square root of 25 minus 4 times 1 is still 4, all over 2 on the bottom. 2 times 1 gives us 2. And finish simplifying, so x equals negative 5 plus or minus the square root, 25 minus 4 is 21, over 2. This is an exact solution. In fact, it's 2 solutions, because remember this plus or minus means there's 2 separate solutions. One of the solutions is negative 5 plus the square root of 21 over 2. And the other solution is negative 5 minus the square root of 21 over 2. We simply save time and energy by writing them together with that plus or minus. But it really means 2 separate answers. This is exact because the square root of 21 cannot be simplified. If we tried breaking down 21, it would break down into 3 times 7. But we cannot take the square root of 3, nor can we take the square root of 7 to get a whole number. So that doesn't help us. We don't worry about doing that. We leave our answer just the way it's written. This example right here is doing the exact same thing. The only difference is you are leaving variables in your formula. So your A actually equals negative m, your B actually equals P, and your C equals negative C. And those are the things you would plug into your formula right here and simplify. The process is just the same, using letters. All right, and finally, average rate of change. Rate of change is the same idea as slope. So if you think back to what you remember about slope, we have a little formula to find the slope. y2 minus y1 over x2 minus x1. Okay, now here's the distinction though. Slope occurs when you have a line, a linear function. These are not linear functions, so you don't have a constant slope, a slope that stays the same between any 2 points. So we use what's called the average rate of change. But again, it's the same idea. The average rate of change will give you that formula and help you to recognize that it's the same as slope. Average rate of change is going to look like this. The function with b plugged in minus the function with a plugged in divided by b minus a. This f of b is the y value when you plug in b. F of a is the y value when you plug in a. B and a are the x values. Okay, so you're doing the same thing. You're taking the function by plugging in a number, getting the y value, subtracting the other y value, divided by the two x values. Alright, so they don't give us a function in this one, simply because I forgot to write it in there. So let me give us a function. Let's say we have f of t equals, make this pretty simple, we'll say negative 2t squared plus t minus 4. Okay, now this is, we'll say plus 4. Again, this is all made up, but I want you to see the process. So a ball is thrown upward from the top of the building. The function below shows the height of the ball in relation to sea level feet, or f of t in feet, at different times t in seconds. So they give us a formula. You would be given a formula. The average rate of change of f of t from t, 3 seconds to 5 seconds, is what? Now, this is not a multiple choice question. When they have a blank written here, this means you actually need to fill in the blank. So, f of t from t equals 3 seconds to 5 seconds. Those are the numbers that are going to go down here. So I'm going to do 5 seconds minus 3 seconds, because I always want to take the later one minus the beginning one. And I'm going to plug them into the function. So if I take f of 5, that means I'm going to do negative 2 times 5 squared plus 5 plus 4 gives us, order of operations, 5 squared is 25 times negative 2 looks like negative 50. 5 plus 4 looks like negative 41 as our answer. 5 is negative 41. That would go here. F of 3, plugging 3 into our function, we get negative 2 times 3 squared plus 3 plus 4. Looks like 3 squared is 9 times negative 2 is negative 18 plus 3 plus 4 looks like negative 11. So I'm going to take minus negative 11. Make sure you keep track of those signs. You have to be subtracting them. And simplify. So negative 41 minus a negative 11. Just think of it as plus the sign. I'm adding it. Here's negative 30 divided by 5 minus 3 is 2, which gives us negative 15. Negative 15 feet. Alright, so one more time. You're going to take the numbers that they give you and plug them into the function. That's where you get those top numbers. Plug them into the function to get the top numbers for your formula. And then the bottom numbers are simply the numbers you plugged in, the 5 and the 3 in this case. And that's it. I hope this was helpful. I wish you the very best on your semester 2 or segment 2 exam, part 2. And have a great day. a number that's going to be between -1 and +1. Now the nice